given problem is solve x square into d square y by dx square plus 2x into dy by dx is equal to log x. Okay, now you observe here they are given first order derivative and it is the second order derivative. So you can say this problem is from higher order differential equation. And moreover, here you observe the dy by dx quotient you have x. Of course 2x is there. What is the x index? 1, and the order of this derivative is 1. And what is the derivative here? D square y by dx square. What is the order of the derivative here? 2. What is the index of x is here? 2. So whenever the index of x and the order of the derivative is equal, then we can say this is this differential equation is said to be homogeneous or Cauchy-Euler homogeneous linear differential equation also we can say, right? Now how to solve this problem? First of all, we have to write into operator form. If you written in the operator form, then you see x square into d square plus 2xd into y is equal to, you have a log x. Okay, by the observation of this problem, what is the derivative quotient? Here you have x terms, and the derivative of quotient is variable. X term is nothing but variable. Here also variable you have. So if one variable is enough, then you can say the differential equation is said to be variable quotients. So whenever the derivatives are with a variable quotient, then we have to convert into constant quotient. How we can convert into constant quotient means we have to substitute here x is equal to log z. Then where what is x is equal to e to the power of z, we need to substitute, where z is equal to log x. And moreover, we have to change this xd also. Xd is nothing but theta. We are denoting with theta. X square d square is nothing but theta into theta minus 1. We have to substitute. What is here d? D is nothing but differential operator with respect to x. And what is the theta? Theta is nothing but x we are changing in terms of e power z. So theta is nothing but differentiation with respect to z. So what we have done now, to convert the variable quotient into the constant quotients, first we are substituting x is equal to e to the power of z, and moreover xd value, x square theta values we are converting into the derivative with respect to z. That's it. Then we can get the given differential equation as a convert into constant quotient. After getting the constant quotient converted into constant quotient, that is in the form of f of theta into y is equal to q of z form. So what is the general solution for this? Means y of z is equal to complementary function plus particular integral. So we have to find out the complementary function and particular integral. So you will get the function in terms of z. After finding the solution, then we have to replace z by log x. Then you will get a final solution y in terms of x. This is the procedure to solve the homogeneous Euler equations, Euler-Cauchy equations. Is it clear for everyone? Right. Now what we have to do, this one we have to convert into constant quotient. Now we are in here. For that what I am doing, put x is equal to e to the power of z, where z is equal to what? Log x. Now xd also we have to substitute. What is the xd here? Theta. And x square d square is nothing but theta into theta minus 1. Now you substitute these all values in the above equation. Then we will have x square d square first, that is theta into theta minus 1 plus 2x, 2 into xd. xd is nothing but theta. So 2 theta into y is equal to log x. You have log x. What you can write? You can write as a z. You can write z. Now you simplify this one. Then you will have theta square minus theta plus 2 theta into y is equal to z. So if you are simplified again, then we will have theta square plus theta into y is equal to z. Now you observe the given problem is converted as f of theta into y is equal to q of z. You see, f of theta into y is equal to q of z, where what is the general solution for this given differential equation? We have general solution is y of z, because this is in terms of z. If it is in terms of x, we will let y of x, but it is in terms of z. So y of z is equal to complementary function plus a particular integral. So first we need to find out the complementary function and then particular integral. Now go for the complementary function. To find the complementary function, we have to treat this q of x as a 0. Okay. Now for that, let y is equal to this, y is equal to e to the power of mz be a solution of f of theta into y is equal to 0. Okay, then we will have the auxiliary equation f of m is equal to 0. Okay, now you observe friends, if you are replaced y is equal to e to the power of mz, then what is the theta y? theta is nothing but what? Derivative of phi with respect to z. That is e to the power of mz derivative is e power mz into z. Mz into z derivative is m. Z derivative 1, mz derivative is m. Next, theta square into y is nothing but here m square into e power mz, because e power mz derivative is m into e power mz. Already you have m. So m into m square into e to the power of mz. Now you substitute these all values in this equation. Then you will have, you see, m square into e power mz plus m into e to the power of mz is equal to 0. So e power mz is a common. Then you will have m square plus m into e to the power of mz is equal to 0. So e power mz is 0 anywhere? Nowhere it is 0. So what you can say? You will have m square plus m is equal to 0. This is in the form of f of m is equal to 0. So this is called the auxiliary equation. And generally we can write directly. But I have explained clearly why we are writing the auxiliary equation f of m is equal to 0. Right? Now we have to simplify this. If you simplify it, you can take m is a common, then m plus 1 is equal to 0. If you are simplified this, then you will have the roots of m are m is equal to 0 and m is equal to minus 1. M is equal to 0 and m is equal to minus 1. In this case, whenever the roots are real and distinct, here the real and distinct, suppose a comma b are two roots are there, then we will have a complementary function of c1 e to the power of ax plus c2 e to the power of bx. Whenever if it is a function in derivative with respect to x, we will write it like this. If it is differentiation with respect to z, what we will write? C1 e power az plus C2 e to the power of bz we will write. So here what is a? You have 0, and what is b? Here you have minus 1. So the complementary function ycf is equal to C1 e to the power of 0z plus C2 e to the power of minus z. Therefore, CF is equal to C1 plus C2 e to the power of minus z. But the complementary function is in terms of z. So we have to convert into from the z to variable x. So what we have to replace for this? We have to replace x is equal to e power z plus z is equal to log x. So if e power z is x is equal to what you have? E power z. Then e power minus z is nothing but x inverse. X inverse is equal to e power minus z or not? So this is C1 plus C2 into x inverse. That's it. This is the complementary function. So in this problem, what we have done means we have done a complementary function. Now what we have to do? Particular integral we need to find out. Up to this is clear for everyone? Now particular integral. We have theta square plus theta into y is equal to z. What is generally particular integral? Particular integral for f of theta into y is equal to q of z. We have ypi is equal to ypi we are denoting with. So 1 by f of theta into q of z. So what is the theta here? You have 1 by theta square plus theta, and what is the q of z? I have z here. So you have to simplify this. Now you observe this is a theta square plus theta, and it is a polynomial equation. So we have to write like binomial. What we can do means here you can take theta as a common. Then if theta is a common, then you will have theta plus 1 times of z. Now this one we can express 1 by theta times of 1 plus theta whole inverse. Can we write like this? Binomial expansion we can do. What is the expression? You have 1 plus x whole inverse is equal to 1 minus x plus x square and so on. Okay. Now we observe, but up to what is the degree you can take x power n, x power 10, x power 11, x power 15, x power 100. That is based on the given polynomial. Right side part what you have? Z. See friends, theta is nothing but differentiation with respect to z. So theta z, differentiation of z with respect to z is 1. Now theta square z is nothing but again one more time differentiation of z with respect to z. So one time if you are differentiated z with respect to z, we have 1. Again if you are differentiated, you will get 0. So highest order whatever it may be, that is you will have finally 0 only. So up to expansion, the highest degree index of x is nothing but here 1 is enough, not more than that. Okay. So 1 by theta into 1 minus theta. Okay, I am writing theta square also for you into, you have z left right side, so that z also I have written. Now multiply inside, then you have 1 into z is nothing but z minus theta z. What is the theta z? You have 1. Theta square z is nothing but 0. That's it. Now you integrate this one. See, first 1 by theta into z minus 1. Now you observe again in the denominator theta is there. Friends, what is the theta meaning? If theta is in the numerator, then we have to differentiate. If theta is in the denominator, we have to differentiate. If theta is in denominator, then we have to integrate with respect to z, because inverse differential operator, this is differential operator, 1 by theta is inverse differential operator, so we have to integrate with respect to z once. Then we will have integral of z minus 1 into dz, so you will have z square by 2 minus z. So now you observe this is the particular integral is in terms of z, so we have to convert z into x terms. For that, what we have to do, we have to substitute z is equal to means z by log x. So you will have the particular integral is log x whole square by 2 minus log x. So this is which value? Particular integral value. Then what is the general solution we have? Y of z is equal to complementary function plus particular integral. But y we are changing in terms of x, so y of x is equal to complementary function. In the previously we are done, that is c1 e power c1 only plus c2 x inverse is nothing but c2 by x. Now the particular integral we have log x whole square by 2 minus log x. So this is the final solution for the given differential equation. So friends, is it clear for everyone how to solve the homogeneous differential equation? That is nothing but Euler-Cauchy differential equation, how to solve, right? Thank you for watching this video.